Okay guys, welcome back. So once again, this is the example that we did in class. So you guys can stop and go at your own pace on this and not have to feel rushed. So one of the big things that I want you guys to realize and to do is how to Google things and how to find things on your own. So the first thing that we need to do is convert our surface pressure from atmospheres to pascals. And so I think that the first thing I would do is go and figure out what that conversion factor is. So if I go to Google and I Google atmospheres to pascals, it tells me that 1 atmosphere equals 101,325 pascals. So when I come back in here, what does that look like? That means I'm taking my atmospheres and I'm multiplying by 1.01325 times 10 to the 5th, which gives me that. The other way I could do that is our convert function. We would want to convert that same number from atmospheres. And if you look here, it gives you a drop-down list of units that it has. So that's pretty cool. But we want atmospheres to pascals. So it tells you what's going on, what it can convert to. So this is a cool function that it teaches you. And you can kind of build in there. So if I click on that and hit tab, it should fill it in for me. And then it gives me the same value. The next thing I want to do is calculate the density of the fluid. So again, if I go to Google and I ask what is the well, first of all, what is specific gravity? Okay, so specific gravity is the ratio of a density of a substance to the density of a standard, usually water for a liquid, or solid, or air for a gas. And so we're looking at a liquid. So I want to find the density of water in kilograms per meter cubed. Google tells me that that is 1,000 kilograms per meter cubed. If I really wanted to go somewhere and find something more specific, I could go to the online library or go look in my chemistry textbook or look at the FE review manual. But I know that's correct just because I've used that number quite a bit. So to do that, I take the specific gravity, which in this instance is 1.26, times 1,000. So it gives me 1260 kilograms per meter cubed. The next thing I want to do is convert, again, we want to convert this from feet to meters. And it tells me that straight up off the bat, so that's really nice. All right, and then I can either drag this guy down and it fill the formulas, or I can just double click. All right, last thing I want to do is calculate the pressure. And so again, the pressure is equal to rho GH, so the density of the fluid times the height times gravity. So we have rho times G times H. So that's actually going to give me my units in pascals, and so I'm going to have to convert back to atmospheres because that's what this is asking me for, and I'm going to have to add in the surface pressure as well. So I want the surface pressure to stay the same throughout because I'm always going to reference the same one. So let's go ahead and convert this, and I'll show you what would happen if we didn't do that. So let's convert that number from pascals to atmospheres. So this number is correct, except for we have way too many decimal places. So let's tone that down to just 3. If I drag this down, what's going to happen, because I didn't use absolute references, is it's going to be referencing the wrong things. So as you can see now, it's referencing gravity as nothing. It's referencing the surface pressure as density of the fluid, and the density of the fluid is nothing. So in order to fix this, what I want to do then is come back here and make sure that I lock these cells in, everything except for my depth. So they have 2, which means that it's going to go back and reference the same column and the same row every single time. All right, so now I can fill that cell all the way down. And so now if I change gravity, if we were somewhere else, all of those numbers are changed. So this is what's beautiful about this, is that maybe we have something with a specific gravity closer to 1.5, and we can make that happen really easily. So that's the purpose of this. Hopefully you guys get better at this and you can use your function and all the things that go with that. So that's one example. I will do a couple other examples and we'll do some more examples in class later.